our world and beyond. Space, in partnership with the European Space Agency.
The Mercury of Roman mythology was an erratic and volatile character, and this swift-moving messenger lent his name to one of the solar system's most mysterious worlds, the planet Mercury.
Mercury is really a weird planet. Normal terrestrial planets, all the rest, have a relation between how big they are and how dense they are. Mercury is not following that rule. It's much more dense than what you would expect for its size. So something went wrong in the formation of Mercury that we don't know.
One of the reasons why Mercury remains mysterious is that it's so close to the Sun. Telescopes find it difficult to observe a small planet against such ferocious light.
Mercury, you must know, is the missing piece in order to understand the evolution of our solar system. We have been to comets, we have seen the other planets, but we do not know a lot about Mercury.
What we do know points to a forbidding world, pockmarked with craters.
Mercury, for us, is a planet of extremes. It has the hottest temperature. There's temperature variations on Mercury, about 600 degrees between day and night. So you have temperature like 400, 450 degrees on the surface during the day, and imagine that's like being in a pizza oven on Earth. So it's really hot there, and temperatures at about minus 175 during the night.
One of the great mysteries of Mercury is its orbit and rotation. It follows an unusual pattern. One day on Mercury can last up to 176 Earth days, and yet 1 year lasts 88 Earth days. Nicolas Rambaud from the Observatory of Paris has spent years researching the rotation of Mercury.
The rotation of Mercury is really unique in the solar system. Mercury rotates 2 times around the Sun in the time that it turns 3 times around its polar axis.
Mercury follows an odd elliptical orbit in which it passes within 47 million kilometers of the Sun and then swings out to 70 million kilometers. All the while it rotates slowly on its axis, meaning the passing of a day on Mercury is like no other.
If you were on the planet Mercury, what you would see is the Sun rising in the east, then it would climb into the sky, and then the Sun would stop at a certain point, move slightly backwards, stop again, and then carry on and set in the west.
The way Mercury turns on its axis suggests that just beneath its thin silicate crust lies a large fluid mantle. It's so dense that scientists believe it must be made from molten iron blended with a little sulfur. And as for atmosphere,
on Mercury we don't talk about an atmosphere, but instead we talk about an exosphere. That's to say something which is very tenuous, basically linked to outgassing due to the solar wind. So there are a few particles that are around Mercury, but it's very, very thin.
Before the first space probes flew to Mercury, some had wrongly assumed it was a rather dull planet, simmering in the heat of the Sun.
Mercury is known since a long time ago. I mean, the Egyptians already give information about the existence of Mercury and recognizing it as a planet. But real observations of Mercury didn't start until much later.
The first signs that Mercury was more mysterious than imagined came when the Mariner 10 mission flew by in 1974. It sent back intriguing images of the surface and picked up signs of a weak magnetic field. Since 2011, the NASA probe Messenger has been orbiting Mercury, mapping the surface in detail. It's picked up signs of ancient volcanoes and of a cooling inner layer. Yet, so much remains to be discovered.
What scientists want to do is try to understand the nature of the planet itself. We want to characterize the surface, what material is on the surface. We would like to measure temperatures. We would like to see the interaction with the solar wind, which is special on Mercury because it's so close to the sun. Then Mercury has a magnetic field, which is like Earth, a dynamo field. We would like to understand that. And so there are several reasons to go to Mercury.
In 2015, Europe should launch its own mission to Mercury. It carries the name BepiColombo in honour of the Italian mathematician. He studied Mercury, and it was his calculations which helped plot the course of the Mariner 10 spacecraft. BepiColombo's first challenge is to successfully reach its destination and avoid the gravitational grasp of the Sun.
The Sun has a lot of gravity, and if you get out of our orbit, Earth orbit, and you go closer to the Sun, and you want to get to the Mercury orbit, you have to be very careful and expend a lot of energy to avoid falling in the Sun.
The journey to Mercury is 6 years and is rather long, because it takes very much energy to travel to that planet. It takes as much energy to travel to Mercury as it would take to travel to Pluto.
BepiColombo should be the most complete exploratory mission to Mercury ever conceived. Construction and testing of the probe is well underway at the European Space Agency's Research and Technology Centre in the Netherlands. The project is a joint mission with the Japanese, and the spacecraft is divided into two, each probe with a specific set of tasks.
BepiColombo has two orbiters. The one is the European orbiter called the Mercury Planetary Orbiter, and it has imaging instruments and spectrometers, but also some instruments to look at the plasma around Mercury. Then there is a Japanese spacecraft, the Mercury Magnetospheric Orbiter, that will operate at a much higher altitude in order to map the magnetosphere and the plasma.
The mission will spend at least a year investigating the geology, interior structure, magnetic field and general dynamics of Mercury. As it does so, it will have to deal with the ferocious heat of the Sun and reflected radiation from the planet. The probe is equipped with special thermal shields and a large radiator to keep the instruments inside at operating temperature.
The planetary orbiter will circle around Mercury, keeping always the instrumentation pointed at the surface. This means that almost all the faces of the spacecraft will be exposed to the high-intensity solar radiation. There is only one side of the spacecraft that we can call the cold face, that carries the radiator and has to be pointed to the cold space in order to be able to reject and radiate all the excessive heat that the spacecraft produces.
BepiColombo should reach its destination by the year 2022. Not only will it offer a new insight into Mercury, but also an idea of how the other rocky planets of our solar system were formed. That, in turn, could offer new clues about other worlds circling distant stars.
Recently, a very hot topic on planetary science or astronomy is extrasolar planets. And many of these planets are in orbits compared to the one of Mercury. So very close to the Sun, very close to the parent star. And so some scientists believe if we study Mercury and understand the behavior of Mercury, then we can also learn something for the extrasolar planets and understand why they are formed or are so close to their parent star.
Planetary scientists are curious to find out how Mercury's orbit and rotation may have changed over its lifetime. That's because many of the distant planets spotted around other stars appear to follow similar paths.
We can make analogies between Mercury and the planetary systems that we discover, the extrasolar systems, where we have planets that are close to their star, but with a highly eccentric orbit. Except that these planets are gas giants, not like Mercury. So the planets themselves are different, but their position is very similar. What's interesting with Mercury will be to understand how this interaction works between the planet and the Sun for a planet that's very close to its Sun.
What happened to Mercury? Why is it so dense? And how did its orbit evolve? Finding answers to those questions could help solve other mysteries too.
We have a theory to understand how planetary systems form, and the solar system is a good example. Now, the theory was based on explaining the solar system, and it was fine, it worked. But now, when we have discovered new planets around other stars in the galaxy, the extrasolar planets, they don't fit at all. So something is wrong. And the special cases, those that are difficult to understand in the details, like Mercury, are very helpful, because it is a case where we find a number of things we don't understand easily.
The fleet-footed messenger of Rome may yet deliver some revealing insights into how our solar system formed 4.5 billion years ago.